Welcome to Matematika. Today we're going to do problems and solutions of lesson 1.2 rates of change. We'll start with set A. Find the average rate of change of the function in the given interval. For number 1, we have the function of x equals the natural logarithm of 3x over the interval from 1 to 4. All right, we're going to do more on natural or logarithm on our incoming units. So for now, we're going to find using the natural logarithm given in the problem. So we have the interval of 1 to 4. So I could make an a equals 1 and b as 4. So I'm going to start plugging in 1. That is f of 1, that is the natural log of 3x. That is natural log of 3 times 1 is equals to the natural log of 3. Okay. For the function of 4, that's the natural log of 3x equals the natural log of 3 times 4. That is the natural log of 12. Okay. So in other words, coming from the formula, I could make this as f of b, and this is f of a. When I plug in the value of a, I come out with the result. So the formula for finding the average rate of change, we have f, the function of b, minus the function of a over b minus a. So what is our function of b? We have the natural log of 12 minus the function of a, the natural log of 3 over 4 minus 1. And that is equals to, using your calculator, get the natural log of 12. You have the value of 2.485 minus the natural log of 3 is 1.0986 over 4 minus 1, that is equals to 3. So subtract 2.485 minus 1.0986. You come up with 1.3864 divided by 3. And that would be equals to 0.462. And this is the rate of change in the interval of 1 to 4 with a given function of natural log 3x. Let's have another function. S of t is equals to 1 over t minus 3 on the interval of 0 to 1. All right. So in this case, I could make this as a and b. The a would be 0 and the b would be 1. So using the given function, I could plug in the s of 0 as 1 over 0 minus 3. This is 0 minus 3. So I have a negative 1/3. All right. When s of 1, that would be 1 over 1 minus 3. That is negative 1/2. All right. Using the formula, this will be my f of b, and this is the f of a. When the a is 0, b when the b is 1. All right. Formula, function of b minus function of a is over b minus a. So our function of b is negative 1/2. minus the function of a is negative 1/3. And then you divide it with a 1 minus 0. So we have a negative 1/2 plus 1/3 over 1. Remember, if we have a fraction like 1/2 and then our denominator is not common, we have to get the least common denominator. 2 times 3, that is 6. So we have negative 3 plus 2, that is equals to negative 1/2. Okay? Negative 1/2, negative 1 over 6. Oops. Negative 1 over 6 divided by 1. So our rate of change is negative 1 over 6. If you divide by negative 1 divided by 6, you have your, in terms of decimal, you can approximate that to a negative 0.1666. And this would be your, rate of change. All right. How about if you are given a table? Use the information in the table to find the average rate of change in the given interval. All right? So you have t in minutes. I could make a division there. D of t in meters. So this is the independent, the x value. And this is the x value here. And it is dependent. If you are given like problems like this, it would be easier for you to do that, especially you are solving, some questions in the test. Be sure you label. Try to label what is given for you. It's easy for you to give out, come out with a formula or come out with the missing number you are looking for. Maybe later on you can able to find those values that you are looking for. So our interval, first interval is 3 to 55 for the independent value. So in other words, if our A is 3, our B is 55. So what is the f of A? When A is 3, you look at the table, the f of A is 5. And what is f of B? When it's 55, the f of B is 143. Right? So you can use now the formula f of B, which is 143, minus f of A, which is 5, over B, 55, minus A, which is 3. So 143 minus 5, that is 138. 55 minus 3, that's 52. And then you divide that, you come up with 2.65. That is meters per minute. Okay? Let's have another interval from 10 to 43. So you could make A as 10, B as 43. You can have the function when it's 10, it's 102. The function when it's 43, you have 140. This is the f of A, and this is the f of B. Oh, function, wait, missed out. Function when it's 43. 43, it is 140. Sorry for that. And this will be your f of B. Okay, start. substituting. So you have 140 f of b minus f of a, which is 102, over b, 43, minus 10. So 140 minus 102, you have 38. Then 43 minus 10, you have 33. So you divide 38 by 33, you have 1.15. I just have it, the answer in hundreds place. So you have in terms of meters per minute. Okay. Let's have the third one. The interval is 21 to 55. Okay. So A is 21, B is 55. So the function when it's 21, it's 135. F when it's 55, 143. You look at the table, right? Just look at the table. Okay, let's do this. So f of b is 143 minus 135 over 55 minus 21. So 143 minus 135, that's 8. 55 minus 21, that's 34. So you come up with, when you divide, that is 0.235. Yeah, meters per minute. Okay, that's it. That is, an easy one. All right, let's do this. In letter C, you are asked to estimate the rate of change of its function at a given point. At a given point. That means this rate of change we are looking for is the instantaneous. All right? Instantaneous rate of change. Now you are given 4, but the example I had given you, we had the table, so it's easy for me to use some values of x when there is a table given, so I could choose which one of the value that is closer interval to the given point. But in this case right here, so our 4 is positive. All right, it's positive. That means I'm going to choose, let's say, a 0.001 lesser. Okay, smaller value, or higher, because this is positive. Sorry for that. This is a positive, so we're gonna add. We're gonna use 3 decimal place. That is, I think that is a very, very close to 4. So let's say our point is 4.001. All right, I want you to use this. Just add, if it's positive, add a 0.001 to the point. If it's negative, you go down by a 0.001. That means you subtract. This, I am adding a 0.0001. All right. So the values that we will be using for our function, we have, I could say, like f of 4.001 and the function of 4. All right. So the point will be also 4.001. So that means my A is 4 and my B is 4.001, because that is the point after 4. And the function of 4.001, what would that be? I will use the function of x formula. The function is given. So this is what we're going to do. The function of 4.001 would be 1 over 3 times 4.001. Okay? So this will become 1 over 12.001. How about for the function of 4? I will just have, 1 over 3 times 4. That is 1 over 12. Okay. So let's try to divide 1 divided by 12.001. You come up with a 0.0833. Sorry. Or if you want to continue to get the exact value, you can have, okay, I'm going to use more digits since this is a very, very close interval. 0.0833, 1251. All right. 1 over 12, when we divide, look at that. 1 over 12.001 is too close to 1 over 12. That's why I'm using more digits. Is also 0.08333, right? More 3, 2, 4. Okay. All right. What's gonna happen? What is going to happen? So I will set up my, rate of change. So I'm gonna have the rate of change here, f of 4.001. I think I don't have a space right there. 4.0, what's going on? F of 4.001, I could set that up, minus the f of 4. This is the B, this is the A. So I should have 4.001 minus 4. Okay, B minus A right here. So that means you're gonna have a 0.0833 1251. Anyway, if you are using the calculator, it's much easier. So you have a 0.0833 121 1251, I mean, minus a 0.08. I'm using this because this is too close. Then minus a 0.001. Okay? So I'm having, when I subtract, I came out with a negative 0.0002079 divided by 0.1. I have a value of negative 0.2079, so approximately a negative 0.0208. This is, I'll make my symbol of approximate value for that. Okay. Now let's look at number 2. Our x value is negative. So when it's negative, we'll try to subtract a 0.001. So when we subtract that, because it's negative, we'll get the lower value. We'll have a negative 1.999. All right. So we're going to do the function. Our a would still be negative 2, and our b is a negative 1.999. So what will be the function of b? That means the function of negative 1.999. Okay, we'll do that and substitute it to the function here. 2 times negative 1.999 squared plus 1. And I think I'm gonna, it's like, the work of a student. I was a student before. Sorry for that. So 2 times negative 199 squared, that would become 3.996, then plus 1, that is, this is 2 times 3.99, that's 7.992, plus 1, that is 8.992. Okay, for the function of negative 1.99. How about if you have the function of negative 2? Okay, let's substitute. 2 times negative 2 squared plus 1. So that would become 2 times 4 plus 1. So that is 8 plus 1. That's equals to 9. Okay, so we have the function now. This is the function of a, and we have the function of b. Okay, so I'm going to set that up, the equation for the rate of change. So what is our rate of change in this case right here? We have the function of negative 1.999 minus the function of negative 2. Then you have a negative 1.999 minus a negative 2. Okay. So let's get the function of negative 1.99. We have the value of 8.992 minus, where's the function of negative 2? That is 9 over negative 1.99 minus 2, that will become plus 2. So you have 0.001. So 8.992 minus 9, you have a negative 0.008, because I'm trying to use my calculator right here. 0.001. When you divide that, you come up with a negative 8. And that is your rate of change. This is, this is the instantaneous rate of change, because you are given a 1 point here. You're not given an interval, but you are given a certain point. And when we do that we are getting the instantaneous rate of change. Let's have letter D. Consider the function g of x equals the square root of 5x plus 2. Okay, find the average rate of change of g of x in the interval of 0 to 3. So I could make right away b. So a is 0, b is 3. So the function when g of 0, that would be the square root of 5 times 0 plus 2. 5 times 0, that is 0. So what is left is square root of 2. The g of when it's 3, so that would be 5 times 3 plus 2. That is square root of 15 plus 2. We have the square root of 17. So this is our f of b, and this is the f of a. Okay. We can set up our, rate of change this time. So our rate of change is g of b minus g of a over, b minus a, or f of b minus f of a, same thing. So I could write, set this up as g of 3 minus g of 0. This is a right here. Over b, which is our b. What's the value of our b? Is 3, right? Is 3 minus, 3 minus 0. Okay. So I could substitute the value now. I have a square root of 17 minus the square root of 2 over 3 minus 0. 3 minus 0 is 3. Get the value of square root of 17, and then you subtract with the square root of 2. You come up, and divided by 3, you come up with approximately, your answer would be 2.71 as your rate of change. Just get the value in the calculator, and then you subtract, and then you divide by 3. Okay. Question letter B. Which has the smaller instantaneous rate of change. Is it at x equals 7 or x equals 9? So we sketch a graph of g of x. We view the graph, then the behavior of the graph to determine what happens to the rate of change in the x values, right? Increase. So if we try to look at this value right here, x equals 7 is right here, right? And x equals 9 right there. So if we try to look at this, just do your observation. Okay, we can see that the function, right, gets somewhat like getting smaller and smaller as we move on to a bigger value of x. Your graph will flatten going to the right. So we can see from the graph without computation that the function get flat. Okay, that means the curve will be going down as we move on, as the x value increase. Like the x value become 17, becomes 18, and go on. It will not, it will flat. That means, what does it means? That the rate of change will be getting smaller and smaller. So if we have a pair of intervals, we could compare, but we are just observing the graph here. We'll try to do that. Getting smaller for the values. Going, move further to the right. So what will happen? Our instantaneous I will write it here. Our instantaneous rate of change will be smaller, will be getting smaller as the x values move to the right, go, or x value increase to the right. So between x equals 7 and x equals 9, of course, as we move to the right, this is 7, this is 9. That means 9, when x equals 9, that is the instantaneous rate of change is smaller. instantaneous rate of change. That's it. All right. Okay, let's do this. A continuous function, all right? F is defined on the closed interval -5 between 5 and 6, okay? And is shown on the graph. For how many values of B from -5, between -5 and 6 is the average rate of change of F on the interval of B and 5, between B and 5, equal to 0. Give the reason for your answer. There is one here that would caught your attention, because the rate of change when it's 0, remember the slope going to the right, going up. When it's straight, that means the slope is 0. So if the average, it says here, the average rate of change equals 0, what will happen? What is the graph would be? What kind of line would be? Or what kind of line do you have? Will it from left down to right up, or from left up, right down, or it is horizontal, or is it vertical? Okay? If it's 0, then it would be, what kind of line do we have? Create a horizontal line because it's 0, right? Because your slope is 0. When slope is 0, how does the line looks like? It's just like that because it's 0 horizontally. All right. So if we have, let's look at this. Let's look at the graph. I'm looking at the graph. What happened? This is somewhere here. This is 5. And I have also another one. 4 is right here. It cannot be horizontal. I want something that is horizontal to this point. 3. Hit the graph. I have the point right here. Is there another one with, let's say we have the function of 5 and it says -2. What will be our y value here? F of x is -2. Same thing with here. They have f of x equals -2. I'm looking from this side right here. If I could have -2. Oh, how about this one right here? I come up with a straight line. My line is not straight. Right there. This point, this is -4. And this point, which is 3 in x, and 5 in x. That means both the f of x, our f of x, would be the f of b, right? That because that is what are the values of b. Would that be the f of x would be -2. All right, so I could say the b, what are the values of b? We have a -4 right here. We have also b equals 3 right there. We have also b is 5. These 3 points form a horizontal line. That means the slope is 0. So when you have, let's say for example, you have the f of b, right? The f of 5. What is the value? The value is -2. Look at this value right here. All of them, the 3, 5, and -4, has an f of b, which is a -2. So these values are the ones giving you a slope that is 0 in the interval of b and 5. Okay? All right. I think I said everything, and then f of 5 is, and then the f of b. So our f of b, whatever b would that be, b of 3, we have a -2. Uh, f of b is -2. If we have a f of -4, the function is still -2. See this right here. All right. And that explains the answer to the question. Just look at the graph, and you can see right away which points that intersect the curve or the graph, and then go straight to the function, the y-axis, and then you can find the f of b, whether um what b would that be, like a or c, then go straight to the y-axis. So that's it. We have solved several problems that is related to the rates of change. And I could say this: if I can do it, so can you. Okay, don't forget to hit like and subscribe this video, and hit subscribe. Okay, see you in my next video.